Hello and welcome to Calculating Z-Scores. We're going to go over what a Z-score is, how to find it, and how we can use it. So let's think about the scenario. The score distributions of each exam your chemistry class takes are approximately normally distributed, right? We talked about last video how a normal distribution looks like that. On the first exam, the class mean was 80, and the standard deviation was 10. On the second exam, the class mean was 75, and the standard deviation was 10. So Lauren scored an 85 on both exams, and they want to know on which exam did Lauren do better. Now, in order for us to actually get a good idea of what's going on, we should draw it out. So let's look at the first test. We have a normal distribution, which means that at the center of it, you have your average, which the problem said was 80. So that goes in the middle. Then the standard deviation is 10. So if you go one standard deviation up, that's going to bring us to 90. Another standard deviation is going to be 100. Because I'm going up by 10. Same the other direction. Go down by 10, a standard deviation, and go down another standard deviation for 60. And we're going to do the same exact thing for the other test as well. So in the second test, we had that the average was 75. Let's pretend my diagrams look the same. So now 75 is in the center, and we still have a standard deviation of 10. So if I go up by 1, I go to 85, 95, 65, and go down another standard deviation to get 55. So usually we only go 2 standard deviations away in both directions because remember we said in the normal CDF lesson that 2 standard deviations away from the mean consisted of 95% of the data. So that's pretty much all of it anyway. It gives you a good idea of what you're looking at. Now we have Lauren's test grade. Lauren's grade was an 85. So in our first one, that is here. And notice Lauren got pretty close to your average, right? She did better than a lot of the other people in the class. Now we have the second one. Lauren's test grade was an 85. That happens to land on one of our standard deviations. And she did a lot better than all of these people in the class. So even though she got an 85 on both exams, which is the same score, which one do you think she did better on? Which one would you rather say you got an 85 on? Now, if you compare both diagrams, you'll notice that the shaded region is larger in test 2. That means that she did better on test 2 when you compare them, compared to the rest of the class. If you think about it here, look, yeah, the average was a 75, and she was 1 whole standard deviation above it. In the other one, the average was an 80, and she was only half a standard deviation above the average. So since she was further away from the average, she did better compared to the rest of the class. So we're going to say test 2 because she did better than more of the class compared to test 1. Think about it this way. When you get 100 on a test, and you look around and all your friends are getting hundreds too, right? Yeah, you're happy about your 100, but it was probably a really easy test if everyone was getting hundreds. Now, if you got 100, but all of your friends got a 70. Aren't you going to feel a lot better about that 100 because everyone else really struggled just to even get a 70? So when we're talking about who did better, we're comparing it to the actual average, how well everyone else did. And that brings us to the idea of a z-score. It's a standardized score. It's the number of standard deviations a score is away from the mean for a normally distributed set of data. So how far are you away from what happens on average? Just like with that other example, if you get 100 but the average was a 70, you would have a really high z-score because you are far away from the actual average. And we calculate that in terms of standard deviations. Make sure you can only use that if you have a normally distributed set of data. Now, before you even get to the formula, let's just talk about what positive and negative z-scores mean. A positive z-score would be to the left of the mean. Go back to the other example. She was above the average, so she's going to have a positive z-score. Same with the other one. So your z-score is positive if you are to the right or above the mean. Your z-score is negative if it is to the left or below the mean. Now, if your z-score is 0, it means you are no standard deviations away because you are on the average. So, z-score. Now, let's talk about what that looks like in a diagram. You have a normal distribution. You know that the center of the normal distribution is your average, right? That's going to be a z-score of 0. Now, if you go one standard deviation up, your z-score becomes 1. Let's say you go another standard deviation away. That is a z-score of 2, and you could go up again for a z-score of 3. If you go below the average, let's say the average on a test was an 80, and you got a 70, you're going to have a negative z-score. So we're going to go to negative 1 standard deviations, go down another standard deviation, and down another. Now, because this is a normal distribution, your graph really should be more symmetrical than my poor drawing abilities. If you are to the right, we have positive. And if you are to the left, you have negative. Now, let's look at the diagram, which you are not given on the Regents, is not on your reference sheet. You have to remember it. It is the value minus the mean over your standard deviation. Now, what the value is what you're looking at. In this situation, we were looking at test grades. So you're basically comparing your test grade to the average, and you're dividing it by the standard deviation. Let's go back to the other example about Lauren and her chemistry scores. Same exact setup going on. Now, we're actually going to calculate the z-scores mathematically using that formula. So, find the z-scores for Lauren's 2 tests above using the z-score formula, which was your value minus the mean over the standard deviation, which I write as SD because I don't want to write it out fully. Now, we have, for the first test, our value that she got on the test, she scored a 85. The average on the test was an 80, and the standard deviation was 10. You're going to put that in your calculator all at once, and you're going to get a z-score of 0.5, which makes sense because if you go back to the diagram, we were halfway between the 80 and 90, right? So that means we're half a standard deviation away. So sometimes you can see it graphically as well. Anyway, we go to test 2 for the other z-score. The value that we got on the test was an 85. In this case, the average on the test was 75, and the standard deviation was 10. If you put that in the calculator, you're going to get a z-score of 1. Now, on which exam did Lauren score better relative to the rest of the class? Well, you're going to pick the one that has the higher z-score because she was higher above the average, right? So, test 2, because her z-score was higher. Now, just to point out, a really important piece of information is that they said relative to the rest of the class. Whenever you're comparing your data relative to something else, that is your cue for z-score. And you want to have that in a lot of your explanations as well. So let's try some practice problems. IQ scores are normally distributed with a mean of 100 and a standard deviation of 15. Find the z-score and interpret it for a student who has an IQ of 90. Really important. They say that it is normally distributed, which allows us to actually do this. So your z-score is your value minus the mean over your standard deviation. Our value here, the person got a 90 on their IQ test. The average IQ is 100, and the standard deviation is 15. You're going to put this in your calculator using alpha y equals, and you get negative 2/3. Or you can rewrite that if you'd like as negative 0.6 repeating. Now, we know that this is 0.666 repeating standard deviations away from the average. Now, the negative tells me I am below the average, which means essentially that this person needs to study a lot more, right? So we're going to say the IQ score is negative 0.6 standard deviations below the mean. Now, actually, before I said the IQ score is negative 0.6 repeating standard deviations below the mean, you don't have to say the negative because you already said below, which indicates that it is negative, right? And yeah, the person definitely needs to study more because the person has a IQ score lower than the average one. For the second one, the prices of printers in a store are normally distributed with a mean of $240 and a standard deviation of $50. The printer you eventually choose costs $340. Find the z-score of your printer and interpret what it means in context. So we have the value of our printer, which was $340. The average value of the printer is $240. And the standard deviation of the printers is $50. If you put that in your calculator, you should get 2. Now, it's positive, which means we paid more than the average printer cost, which is pretty obvious if you paid $340 and the average printer is $240. But because you're 2 standard deviations away, you paid a lot more than the average printer actually costs. So the cost of the printer is 2 standard deviations above the mean. let's look at how else we can use z-scores. So recall a z-score shows the number of standard deviations a score is away from the mean. If you are at the mean, the z-score is 0. Therefore, when we are referring to a z-score, the mean is 0. And the standard deviation will always be 1. And I'm just putting the symbols in with it. So let's see how to use that in a problem. We're going to go back to normal CDF with z-scores. They want you to find the percent of scores that fall between z-scores of negative 0.6 and 0.6 on the normal curve. Round your answer to the nearest thousandth. Now, I know I'm going to need normal CDF because they're asking you to find a percentage of how many scores fall between a certain interval, and they're telling me it's a normal curve. So we're going to start this out like usual. In the center is going to be my average. Now, when you're talking about z-scores, we already said up top that the average is 0 because you are exactly right on the average. You're not straying away from it at all. From there, we're looking at negative 0.6 and positive 0.6. So we're finding this area. Now, our lower is negative 0.6. That's the lowest number in the shaded region. The largest number in the shaded region is 0.6. Your mean is 0, and your standard deviation is 1. So again, on your calculator, you're going to go to second vars because that's where it says distribution. You're choosing normal CDF, and we're going to input our information. Please make sure you use the negative instead of the subtraction sign. If you're getting an error, that's probably why. Also, if you're getting an error, it could be because you switch your lower and your upper. If you put the negative 0.6 in the upper section, you won't get an answer. If you have the calculator app that's different than the Texas Instrument one, you will have to actually go and type in all of your information horizontally like this. Your first number here should be your lower, then your upper, your average, and then the standard deviation at the end, and put commas in between everything. Anyway, you get an answer of this. So let's bring it over. Oops. Now, this problem does say to round to the nearest thousandth, but it also wants it as a percentage. Now, that means we're going to change it to a percent first and round last. So I'm going to have 45.14938.709%. And now you're going to round it to the nearest thousandth, which would be 45.149%. Let's try another one. Find the percent of scores to the left of negative 2.40. So we're going to make another normal distribution. That was awful. Let's try again. Not that much better, but I'll take it. Because this is a z-score, your average is 0 because you're right on the mean. Then we're talking about to the left of a negative z-score. And to the left would be this region. Now, that's not a lot of the graph, so you should not have a large answer. Your answer better be small. Now, your lower would be, well, there is no lower number, right? And when there's no lower number, you're going to pick 1,000,000. Just choose a very large number. It doesn't matter if you have more zeros. Just don't make it smaller. Then your upper, the largest number of the shaded region is negative 2.4. Your mean should be a 0, and your standard deviation is 1. We're going to go and put that in the calculator. Second bars, normal CDF, negative a million, negative 2.4, and let's see what we get. We get that. All right, that is a very tiny number, and I told you to be on the lookout for that anyway. Now the problem does ask you to find a percent of scores. It's not telling you how to round in this case, so we will round to the nearest tenth, let's say. So it's different than the last one. Let's see. We will make that 0.8%, or however you chose to round for that one. So keep in mind that z-scores figure out how many standard deviations you are away from the average. You do have to remember the formula for it, which is value minus mean over your standard deviation. We should know that if you have a normal distribution, your center, the mean, is going to be 0. If you are to the right, you have positive z-scores. And if you are to the left, you're going to have negative z-scores because you are below the mean. And that's all for this video.